Welcome to class and welcome to Simple Science. Today we have quadratic equations and I'm going to show you how to solve quadratic equations using completing the square method. It's one method that quite a lot of students do not know how to use. And in this video, I'll also prove the formula method using completing the square method. I'll also prove the formula. A lot of scholars call it the almighty formula, but it's not the almighty formula. It's called formula method for solving quadratic equations. So in this video also, I'm going to prove that formula from completing the square method. So join me. The first thing you should know is that a quadratic equation is an equation that is in the form y is equal to ax squared plus bx plus c. Any equation in this form. And the roots of the equation occur where y is equal to 0. So if you have something like this, and then you have ax squared plus bx plus c is equal to 0, then this is a quadratic equation where a, b, and c are constants. So a is a constant, b is a constant, c is a constant. What do we mean by that? You may have something like 2x squared plus, let's say 5x plus, let's say 3 is equal to 0. So this is a quadratic equation. And you have your a to be the coefficient of x squared. So your a is equal to 2. Your b is equal to 5. And your c is equal to 3. 3, let me use plus to show that they are positive. So, or you can choose not to put the plus sign, but you know that 3 is a positive number, is a positive whole number. So you have your a, b, and c to be this. So this is an example of a quadratic equation. There are other quadratic equations as well. Now, there are methods of finding the solution to a given quadratic equation. Actually, there are 4 methods. The first method is factorization method. The second method is completing the square method. Completing the square. The third method is formula method. Formula method. And the fourth method is graphical method. Graphical method. So quite a number of students know how to use the factorization method, but the factorization method does not work on all quadratic equations. There are some quadratic equations that are not factorizable to say, and so completing the square method will be a very good approach to questions like that. And also, formula method is also a good approach to questions like that. A graphical method is also another important method of finding the solutions to any given quadratic equation. But in this video, I'm going to show you how to use completing the square method. It's not as difficult as you think. So let's get started. So we have, let's say, completing the square method. Completing the square method. So let's say we have ax squared plus bx plus c is equal to 0. So we have this on the board and we want to use completing the square method to finding the solution to any given quadratic equation. So the first thing we do is to, I'm going to give you the steps one after the other, and then steps. The first step is to make the coefficient of x squared, that is a. The coefficient of x squared is a, so make the coefficient of x squared unity. That's 1. So the first step is to make sure that your a is equal to 1. That's the coefficient of x squared is 1. And then the second step, move the constant to the right hand side. Remember that a quadratic equation has two sides. This is the left hand side and this is the right hand side. Your constant is c. C is the constant because it is the only term that is independent of x. It does not have x attached to it, or it is not attached to x. It is just an ordinary number or a value given. So you move the constants to the right hand side. Then after doing that, the third step now has 3 sub steps. So from that third step, the first part of that third step is take half of the coefficient, of x, that is b over 2, that is half of b over 2. The first thing in step 3 is to take half of the coefficient of x. The coefficient of x is b, the coefficient of x squared is a. So half of the coefficient of x will be b over 2. And then when you take half of that coefficient, the second thing is to square it. Let me say b over 2a, sorry. That's if we divide both, if we try to make our a unity. Square it, and then the third thing is to add it to both sides. So you take half of the coefficient of x, that will be over 2a, you square it, and then you add it to both sides. And then when you've done that, the fourth step is to factorize the left hand side. Factorize the left hand side to become this will be x plus half the coefficient of x all squared. So that's what you're going to have, x plus half the coefficient of x all squared. That will be on the left hand side. Don't bother, when we're going to treat an example, you see how we apply each of these steps. And then the fifth thing to do is to simplify the right hand side. Simplify the right hand side. So you solve that right hand side. And then when you solve that right hand side, you will get a value. And the sixth thing will be to take the square root of both sides. Take the square root of both sides. And then after you've done that, the seventh step will be that you should make x the subject of the formula on the left hand side and simplify the right hand side. So you make x the subject of the formula on the left hand side and simplify the right hand side. So these are my 7 step solution to completing the square method in solving any given quadratic equation. So let's get started. I'm going to leave this part of the board so that we can look at the steps and then we see how we apply these steps. For instance, let's say we have a given question. So we have given, let's say we have x squared minus 5x plus 6 is equal to 0. So let's assume we want to solve this given quadratic equation using completing the square method. So step one is that we make the coefficient of x squared unity. Look at, in this case, don't forget that our a, let me write it here, our a is equal to 1 is unity already. Our a is equal to 1, the coefficient of x squared is 1. Our b is equal to -5, and our c is equal to 6 plus 6. So our a is 1, our b is -5, and our c is +6. You will notice that our a is already unity. The coefficient of x squared, that's our a, is already 1. So step 1 has been done. There will be no need to apply step 1 because the coefficient of x squared is 1 already. So we move to step 2. Step 2 is to move the constant to the right hand side. So step 2, move the constant to the right hand side. So we have, this is our constant, c is our constant, so we move it to the right hand side. This is the left hand side and this is the right hand side. So we have x squared minus 5x will be equal to -6 when we move our constant to the right hand side. So we are done with step 2. And then step 3, here we come. Step 3 says we should take half of the coefficient of x. We should square it and we should add it to both sides. So half the coefficient of x will be b, because the coefficient of x is b, which is -5 in this case. So half of it will be -5/2. This is half of the coefficient of x. We will square it, and then it is this value we will add to both sides. Please take note of the pattern in which I'm presenting the solution. We do not need to work on this bracket. We don't need to simplify this bracket. We don't need to apply these squares to this bracket for now. We need to use it like this. So this is half of the coefficient of x squared. This is half times the coefficient of x squared of x is -5. So this will give us -5/2. That's half of the coefficient of x. In this question, we'll square it and we'll add it to both sides. So let me write it. Take half the coefficient of x, and then you take half the coefficient of x, we square it and add it to both sides. So half of the coefficient of x is -5/2. So we have x squared minus 5x plus, remember that we are adding it to both sides, then we have -5/2 all squared. So this is half the coefficient of x, this is the coefficient of x, this is half of it squared. We have squared it and we have added it to the left hand side, equal to -6 plus -5/2 all squared. So we have added it to both sides now. So when we've done that, step 4 says we should factorize the left hand side. Step 4 says we should factorize the left hand side. So if we factorize this left hand side, we will have, okay, let me write the step, factorize the left hand side. So we'll have this, this will be x, please watch, this will be x plus what you have in this bracket, this will become -5/2 all squared. By this, we have completed the squares on the left hand side, and it is from this part of the question that the name was derived. So we have completed the squares on the left hand side, and then we have it to be this. This will be x plus, then you have this, whatever you have in this bracket, you bring it here, and they'll be all squared. This will be equal to -6 plus -5/2 all squared. So we can work on this bracket. We can work on this to be x plus times minus will give us 5 over 2 all squared. This will give us minus 6. Plus times minus will be minus 5 over 2. Minus 6. This will be plus, and then minus 5 over 2 squared will be minus 5 over 2 times minus 5 over 2. Minus 5 times minus 5 will give us 25 all over 2 times 2 will give us 4. So we'll have 25 over 4 on the right hand side. So we have it to be like this, and we have already started simplifying the right hand side. So the next step we have, remember step 4 says factorize the left hand side to be x plus half the coefficient of x all squared. So we have x plus, this is half the coefficient of x all squared. So we have done that. Then step 5 says simplify the right hand side. So if you look at the right hand side, we need to simplify it. So let's simplify it. We have x minus 5 over 2 all squared is equal to minus 6. We can remove these brackets to give us plus 25 over 4. And so we have that x minus 5 over 2 all squared is equal to, if we simplify this, this will give us, if we take the LCM of, this will be over 1. So the LCM of 4 and 1 will be 4. So 4 divided by 1 is 4. 4 times minus 6 will be minus 24 plus 4 divided by 4 is 1. 1 times 25 is 25. This will give us minus 24 plus 25 is 1 over 4. So we have x minus 5 over 2 all squared is equal to 1 over 4. So with this, we have simplified the right hand side. We have simplified the right hand side. And so the 6th step says take the square root of both sides. So we take the square root of both sides because we want to make x the subject of the formula now. So at this point, our focus is to make x the subject of the formula, and that will give us the final answer. So we'll say step 6, sorry. Okay, this was step 5. This was step 5, and then step 6, for us to take the square root of both sides, because we want to make x the subject of the formula. So we have, if we take the square root of both sides, square root of this side, we cancel the squares here. So we'll have x minus 5 over 2. This will be equal to plus or minus square root of 1 over 4. Or let's say if we take the square root of both sides, taking the square root of this squared equals to this plus or minus square root of this. The squares, we cancel the square root, and we have that x minus 5 over 2 is equal to plus or minus square root of 1 over 4. Now, we know that the square root of 1 is 1, and the square root of 4 is 2. So in place of this, we can say this will be plus or minus 1 over 2. So x is going to give us, step 7 now says that we should make x the subject of the formula on the left hand side and simplify the right hand side. So step 7, we make x the subject of the formula. From here, we move this one to the right hand side. So x will be equal to 5 over 2 plus or minus 1 over 2. This will be equal to 5 over 2. Okay, so we have, because the denominators are the same, we'll take one of them. This will be 5 plus or minus 1 all over 2. So if we do this, we'll have x is equal to 5 plus 1 all over 2, or 5 minus 1 all over 2, because we have plus or minus. Therefore, x will be equal to 5 plus 1 is 6, 6 over 2 will be 3, or 5 minus 1 is 4, and 4 divided by 2 will be 2. So this will be our answer for this question. So x will be equal to 3 or 2. So this is how to go about it. The first step is to make A to be unity. And from our question, we have that our A is equal to 1, is unity already. And then we take half the coefficient of x, that's minus 5 over 2. We square it and we add it to both sides. So that's what we have here on the left hand side and on the right hand side. The next thing, we factorize the left hand side to give us x plus half the coefficient of x all squared. And then when we've done that, the sixth step, we simplify the right hand side, and then the sixth step, we take the square root of both sides so as to cancel the squares on the left hand side. And then when we've done that, the seventh step is that we make x the subject of the formula and we simplify the right hand side. So this is how to go about solving a question like this. So let's have another example. Let's say that we have 3x squared minus x minus 2 equals to 0. So let's say we want to solve this question using completing the square method. So how do we go about it? We have step 1, which is the first step. The first step, step 1, says that we should make the coefficient of x squared unity. That means what should come before x squared should be 1, not 2 or 3, not minus 2 or minus 3. The coefficient of x squared should be 1. So how do we do that? We divide both sides by 3. So step 1, we divide both sides by 3. So we'll have that here we have x squared minus x over 3 minus 2 over 3 is equal to 0 over 3. 0 over 3 is still 0. So we have this. And then, or let's say we have 3x squared over 3 minus x over 3 minus this. So 3 can cancel 3 and we'll still have x squared. We can write this like this, x squared minus, we can write this to be 1 over 3x. Yes, we can put it like this, minus 2 over 3 is equal to 0. Then we come to the next step. The next step says move the constant to the right hand side. So here we have step 2. Step 2, we move, so this is our x squared and the coefficient is now 1. This is our A is 1, our B is now minus 1 over 3, our C is now minus 2 over 3. So we move the constant, that's C, to the right hand side. And then we'll have x squared minus 1 over 3x will be equal to 2 over 3. That's step 2. Then step 3 says that we should take half of the coefficient of x, square it, and add it to both sides. So half of the coefficient of, remember that the coefficient of x is minus 1 over 3. If we take half of it, we'll multiply it by 1 over 2. This will give us minus 1 over 6. So this is minus 1 over 6 is half the coefficient of x. Then we will square it and then we'll add to both sides. So how do we do that? So this is what we have. This is half the coefficient of x. This is the square. So this is what we are going to add to both sides. So we have something like this. X squared minus 1 over 3x plus, remember that we are adding to both sides, plus, you open bracket, minus 1 over 6 all squared is equal to 2 over 3 plus, bracket open, minus 1 over 6 all squared. So that's what we have. This can go out. So that's what we have. And then step 4 says we should factorize the left hand side. So step 4, we factorize the left hand side. And how do we factorize? Please watch. We factorize to be like this. X, this will be x plus what you have in this bracket, because we have completed the squares now, so we can factorize it to give us a square. So we have x plus, you have minus 1 over 6 all squared. So you take one of these and take what is inside this bracket. So this will be equal to 2 over 3 plus minus 1 over 6. Meanwhile, let's work on this part. You know, minus 1 over 6 squared will be minus 1 over 6 times minus 1 over 6. So minus 1 times minus 1 will give us 1, all over 6 times 6 will give us 36. So we can work on this to be plus 1 over 36. So we have it to be like that. And then step 5 says we should simplify the right hand side. So we will still have x plus times minus will be minus 1 over 6 all squared will be equal to, here we have 2 over 3 plus, we can remove the brackets to give us 1 over 36. And so here we look for the LCM of 3 and 36. We have x minus 1 over 6 all squared is equal to, the LCM of 3 and 36 is 36. So 36 divided by 3 is 12. 12 times 2 is 24 plus 36 divided by 36 is 1. 1 times 1 is 1. So this will give us 25 over 36. And so we'll have that x minus 1 over 6 all squared will be equal to 25 over 36. So we have it to be this, and step 6 says, step 5, we simplify the right answer. So this is step 5, this is step 5. Then step 6 says take the square root of both sides. Step 6 says we should take the square root of both sides. So we want to remove the squares here so we can make x the subject of the formula. So we take the square root of both sides and we'll have that, root x minus 1 over 6 all squared is equal to plus or minus root 25 over 36. So square, we cancel square root, and then we have that x minus 1 over 6, we can remove the bracket now, will give us square root of 25 is 5, plus or minus square root of 25 is 5, and then square root of 36 is 6. And so step 7 now says we should make x the subject of the formula on the left hand side, and we simplify the right hand side. So we come to step 7, and then we make x the subject of the formula. So we move this to the other side. So x will be equal to, this will become, when minus 1 over 6 crosses over, it will become 1 over 6, minus will change to plus, plus or minus 5 over 6. So we have that, because the denominators are the same, this is also equal to 1 plus or minus 5 over 6. Because the denominators are the same, we'll take one of them. So x is equal to 1 plus 5 over 6 or 1 minus 5 over 6. So x is equal to 1 plus 5 is 6. 6 divided by 6 will be 1, or 1 minus 5 is minus 4. Minus 4 divided by 6 will give us minus 2 over 3 as our answer. So this will be the final answer. So this is how to solve questions like this. If you're an expert rather in finding the roots of a given quadratic equation using factorization method, you can try to find the root of this equation using factorization method. You will find out that the answer will be the same. Even if you want to use formula method, the answer will still be the same. Now you may be wondering, why do we have to go through the rigors and the stress of completing the square method? Well, you need to know it because not all quadratic equations are factorizable in themselves. There are some that you may not be able to factorize them, and the only way to find their solution is either you use completing the square method, or you use formula method. Secondly, you may be instructed to find the roots of a given quadratic equation using a particular method. So if you should feature in an external examination or in a quiz session or in an assessment, and you're told to use the completing the square method, even if that question is factorizable, you need to use completing the square method. If you don't use the method that is stated, you will not earn the marks. So that's also another reason you need to know this. So this is the answer. And lastly, I'm going to prove the formula method. I'm going to show the proof for the formula method so that you can use it to cross-check other questions. Proof of formula method using completing the square method. Completing the square method. So we have that given ax squared plus bx plus c is equal to 0. So we are given this, and this is the general form of a quadratic equation. We know that the roots occur where y is equal to 0, and that's what we have done here. So remember that we have our steps on this side. So the first step, step 1, is to make the coefficient of x squared to be unity. That means that our a should be equal to 1. So what do we do? Step 1, due to I want us to look at the steps written here so that I'll be reading the steps and I'll be applying them to the to solving the question, so we have a proper understanding of how to apply them. So step 1, make the coefficient of x squared unity. So how do? We divide both sides by a. When the coefficient of x squared is not 1, if it is 2, 3, 4, minus 10, or anything other than 1, you need to divide through by that value so that it will cancel out. So step 1, we divide both sides by a. So we have ax squared over a plus bx over a plus c over a is equal to 0 over a. So a will cancel a and we'll have x squared plus, I can write this as b over a x plus c over a is equal to 0 over a is 0. So I can express it like this: b over a times x plus c over a. Step 2 says we should move the constant to the right hand side. So step 2, we move the constant to the right hand side. So we have x squared plus b over ax is equal to minus c over a. When plus c over a crosses over, it becomes minus. We have this. Step 3, the third step says we should take half the coefficient of x, square it, and then add it to both sides. So the coefficient of x is b over a, so half of it will be half times b over a, and half times b over a will give us 1 times b will give us b over 2a. So this is half the coefficient of x. We'll square it, and then this is the value we'll add to both sides. We'll add b over a over 2a squared to both sides. So here we come. In step 3, we have this will be x squared plus b over ax plus, we open our bracket, we have b over 2a all squared. This will be equal to minus c over a plus, remember that we are adding this to both sides, b over 2a all squared. So we've done this, and our step 4 says we should factorize the left hand side. If we factorize the left hand side, the left hand side will automatically become x, bracket open, x plus half the coefficient of x, bracket close, squared. So this will become step 4. Step 4, this will become, we take x, we open bracket, take x plus whatever we have here, we have b over 2a, and then we square it. You will notice that we have completed the squares on this side. That's why we can completely factorize. And this method is derived from this step. And that is why it is called completing the square method. So we have this will be equal to minus c over a plus, we can expand this, we can open this bracket by applying the square. So this will be b squared over 2a squared will be 2 squared will be 4, and a squared will be a squared. So we have over 4a squared. So we have this. Now step 5 says we should simplify the right hand side. So step 5 to simplify the right hand side. So we have our x plus b over 2a all squared is equal to, if we take the LCM of a and 4a squared, the LCM will be 4a squared. 4a squared divided by a will give us 4a. So 4a times minus c will give us minus 4ac plus 4a squared divided by 4a squared will have 1. 1 times b squared will give us b squared. So we can express this as, we can bring the positive first and the negative to follow. So we can say this will be b squared minus 4ac all over 4a squared. What we have done, we brought the positive first and the negative behind. So we have that x plus b over 2a all squared is equal to b squared minus 4ac all over 4a squared. So we have it to be this. Step 6 says we should take the square root of both sides so that we can cancel the squares on the left hand side. So step 6 says I should take square root of both sides. We should take the square root of both sides. So we have that the square root of x plus b over 2a all squared is equal to plus or minus square root of, when we are taking square root we include plus or minus, and the reason is that the square of a positive number or a negative number will give you that number. So if you have 2 plus 2 squared will give you 4, minus 2 squared will also give you 4. So so the square root of 4 will be equal to plus or minus 2. So that's why we have it to be this, and then this will be plus or minus square root of b squared minus 4ac all over 4a squared. So we have it to be this, and here squares can cancel square root. So we have x minus b over 2a is equal to, from sorts, if we have root a, if we have root a over b, this is the same thing as square root of a all over square root of b. So we can express this left hand side to be something like this, plus or minus square root of b squared minus 4ac all over square root of 4a squared. And square root of 4a squared will give us 2a, because square root of 4 is 2, square root of a squared is a. So x minus b, I can remove the bracket now, minus b over 2a is equal to square root of b squared minus 4ac all over 2a, sorry, plus or minus. Therefore, we come to step 7 now. Step 7 says we should make, this is step 7. Step 7 says we should make x the subject of the formula on the left hand side and simplify the right hand side. So for step 7, we make x the subject of the formula. We move this to, sorry, this should be plus. We've been using minus, this should be plus from here, plus. So we move this to the other side, and we'll have x will be equal to minus b over 2a plus or minus square root of b squared minus 4ac all over 2a. So because the 2a and 2a are the same, we'll take one of them. So we have that x will be equal to minus b plus or minus square root of b squared minus 4ac all over 2a. So this becomes the final answer and the proof for the formula method of finding the roots of any given quadratic equation. One beautiful thing is that a given quadratic equation can be solved using this method. The formula method can solve any kind of quadratic equation, and even completing the square method can do that as well. Can do that. They can be used. So mind you, this is for formula method, not almighty formula. We use almighty when we are referring to God, but then this is known as formula method. The only ones it may not be able to solve very correctly, even if they are complex, because if the roots are imaginary and complex, I'm going to explain that in a subsequent video. If the roots are imaginary and complex, you will also be able to figure it out if you're using completing the square method or if you're using formula method. So this is how to go about it. You can go over it again and again until you have the mastery. And then don't forget to like the video, subscribe to the channel, that's if this is your first time, and then share to your friends so that they can have access to knowledge. And then drop your comments in the comment section. And very importantly, don't forget to try your hands on the hands-on session that you will find at the end of the video.